Hi class, Mr. Morris. We are going to be talking today about something called hydrates. You'll want to open up this periodic table link. We're going to be referring to periodic table. You might want a calculator handy because we're going to be doing some calculations. Hydrates are substances that include water in their formula. They're usually ionic compounds that also are attached to a water molecule, sort of. So the water is not really exactly part of the chemical substance. That's reflected in the way that we write the chemical formula. So an example would be CuSO4. You've got a raised dot and 5H2O. The formula means that for every one copper sulfate, every one of these copper 2 sulfate formula units in the substance, there are also 5 water molecules. For every copper sulfate, you've got 5 waters. Hydrates are not necessarily wet. They're usually not. Copper sulfate pentahydrate, we'll learn how to name that later, but that's what this is called. It actually appears dry. There's a picture of it right here. The dark blue substance on the left here is that substance there. There are some hydrates that have a wet appearance, but most of them are perfectly dry to the touch and to the eye. Okay. So here are some examples. You've got copper sulfate pentahydrate, which we just learned about. This one right here. And if it was just copper sulfate, so if I remove those 5 water molecules, it wouldn't look any more dry, but it does have a different appearance. It actually is not as vibrant of a blue color. And then magnesium sulfate heptahydrate, that's what this is. That's called Epsom salt. You probably have heard of that, or maybe you may even have some at home. It's just got a slightly different appearance to magnesium sulfate, which is if you were to remove all of the water molecules from it. So they're not necessarily wet. A couple things I want you to know when you're looking at these formulas. The dot is not a multiplication sign. It's really important to recognize that. It's not meant as a mathematical operator. In fact, it just tells us that there are 5 water molecules for every 1 copper sulfate molecule. So when we're finding the molar mass, which we'll do in a little bit, we're actually going to use that more like a plus sign. So we will add the mass of 5 waters to the mass of copper 2 sulfate. All right, the name of CuSO4 5H2O, and I've said this a couple times, the name of it is copper 2 sulfate pentahydrate. That's the right name for it. Notice the penta means 5. So you see this right here. Penta means 5. Hydrate means water. Now the rest of the name you should know from when we named ionic compounds, or you should be able to figure that out. Sulfate has a -2 charge. Copper has to have a +2 charge to balance it out. That's how I know it's copper 2 sulfate. Okay. Penta means 5. Hydrate means water. Use this name when you're writing it or when you're speaking it. We don't just call it copper 2 sulfate 5 waters. I did that once or twice because you hadn't heard the name yet, but that's not the right way to refer to it. You call it copper 2 sulfate pentahydrate. That's the name of it. The percent composition can also be calculated based on the hydrate formula. We'll be using the mass of water a lot, so it's a good number to know. Let's work through it. Okay, the molar mass of water is equal to, well, hydrogen is 1.008. We have 2 of them, so we're going to do 2 times 1.008 plus, and then we've got oxygen. Go back over here. It's a good mass to know, 15.999. All right, and add those together. You're going to get 18.015 grams per mole. Okay, so that's our molar mass of water. Okay, we're going to calculate the percent mass of water in CuSO4 in copper 2 sulfate pentahydrate. Okay, so there's a few things we need to know in order to find the percent mass. Now you might not remember the percent mass formula. Let's review. Okay, percent mass of water, in this case that's what we're looking for, percent mass of water equals, and we're going to make a fraction here, mass of H2O, and you do have to take into account that 5, so it's 5 H2O molecules divided by the mass of the hydrate, which is the whole thing, copper sulfate pentahydrate. And then we're going to multiply by 100 to get the percent. That's how we're going to find it. Okay. So there's a few things that we need to know. It's a good idea to go ahead and figure out the molar mass of copper sulfate, because we're going to be using that down here, and it's just a useful way to solve this. So copper sulfate, I'm going to find copper. Cu is going to be a transition metal. There it is, 63.546. And I'm going to add it to the mass of sulfur. Go back to our periodic table. Sulfur is a nonmetal. It's 32.066. Plus 4 oxygens. So we're going to do 4 times the mass of oxygen, which is 15.999. Okay. And when you put that in your calculator, I believe you're going to get 159.608 grams per mole, unless I've made an error, which is possible. And then we have 5 water molecules. So multiply 5 times the mass of water, which we just found up here, 18.015. Remember, the molar mass of water, is going to be our molar mass of 5 waters, because we have 5 waters for every one of the copper sulfate formula units. Multiply that out, you're going to get 90.075 grams per mole. And then down here, when I add those two together, I'm going to get my total molar mass of the hydrate. So add those two together, you end up with 249.683 grams per mole. And that was just adding these two numbers together because it's the mass of both of them. Okay, so the percent mass of water in copper 2 sulfate pentahydrate is going to be equal to, let's set up our equation with fraction, mass of the water over the mass of the hydrate. So we're going to have mass of the water is 90.075. It's mass of what I'm looking for, divided by the mass of the hydrate, which is 249.683. And then, of course, we're going to multiply by 100. When you do that, you come up with something like 36.08%. All right. Now the next question asks us to calculate the mass of the percent mass of copper 2 sulfate in copper 2 sulfate pentahydrate. Now, if you were doing this on a test, there's a much faster way to solve this than what I'm going to do, but I want to work through the process one more time just to get some practice. But if you were asked this question, both of these questions in sequence on a homework assignment, a quiz, or a test, and you wanted to solve it a little more quickly, it's just 100% minus this is going to give you the percent of the other component, which is copper 2 sulfate. So that's one way that you could solve it, but right now we want to practice. So I want to find the percent mass, this time not of water, but the percent mass of copper 2 sulfate. Okay, so what I need is the mass of the copper 2 sulfate, which is right here, 159 point, and let's actually write that out, percent mass of CuSO4 in CuSO4, raised dot is right here, pentahydrate. The way we're going to find that is by making a fraction. We're going to put the component I'm looking for, which is copper 2 sulfate, 159.608. It's the molar mass that comes from copper 2 sulfate, divided by the mass of the hydrate, which is 249.683. And then we're going to multiply by 100. When you do that, you're going to come up with 63.92%, which should be the same as what you had gotten if you subtracted from 100 here. Or if you were to add these together to check your work, you should get 100 or at least something very close. In this case, I think it's exactly 100. Okay, that's it for the first page of notes. The next page is actually talking about determining the hydrate formula from percent composition.